Hello students, I'll continue with the important 4-mark questions on the continuity and see this question. Find the values of k so that the function f is continuous at x equal to 5, where f of x is equal to, and it is given that the function is continuous at x equal to 5. Here, what is f of x? Kx plus 1 if x less than 5, 3x minus 5 if x greater than or equal to 5. It is given. And f of x is continuous at x equal to 5. Suppose the function is continuous at x equal to 5, then the left hand limit and right hand limit are equal and equal to value of the function. That is limit extending to 5 plus f of x is equal to limit extending to 5 minus f of x equal to f of 5. And now limit extending to 5 plus f of x. 5 plus means it is greater than 5. When it is greater than 5, function is defined as 3x minus 5, and in place of f of x you have to replace by 3x minus 5, and that is limit extending to 5 plus 3x minus 5. Limit extending to 5 minus means slightly less than 5. When it is less than 5, f of x is defined as kx plus 1. You have to replace f of x by kx plus 1, and that is limit extending to 5 minus k plus 1. And what is f of 5? When x equal to 5, it is 3x minus 5. That is 3 into 5 minus 5. That is 15 minus 5. And let us find the limit of the function, limit extending to 3x minus 5 and limit extending to 5 minus kx plus 1, and that's equal to 3 into 5 minus 5, and limit extending to 5 minus kx plus 1 is equal to 5 into k plus 1. Here put x equal to 5, k into 5 or 5k plus 1. And what is 3 into 5? 15 minus 5, that's equal to 10, is equal to 5k plus 1. And you bring 1 to left hand side, you will have 5k is equal to 9 and k is equal to 9 by 5. Now see the next question. Find the values of a and b such that the function defined by f of x is equal to 5 if x less than or equal to 2, ax plus b if 2 less than x less than 10, and 21 if x greater than or equal to 10 is a continuous function. And given function is continuous means it is continuous everywhere, and let us use the continuity at the point where the function switch over. That is f of x is equal to 5 if x less than or equal to 2, ax plus b if 2 less than x less than 10, 21 if x greater than or equal to 10, which is given function, and it is given that it is continuous. And it is continuous means it is continuous at x equal to 2 and at x equal to 10 also. It is continuous everywhere, and let us use the continuity of the function where the function switch over, and using that it is possible to get the value of a and b. Now limit extending to 2 minus f of x is equal to limit extending to 2 plus f of x equal to f of 2, because f of x is continuous at x equal to 2. And similarly, f of x is continuous at x equal to 10. Therefore, limit extending to 10 plus f of x is equal to limit extending to 10 minus f of x equal to f of 10. And let us use these two results, and you will get two equations in terms of a and b. First, let us use this result, limit extending to 10 plus f of x is equal to limit extending to 10 minus f of x equal to f of 10. That is limit extending to 10 plus. 10 plus means greater than 10, slightly greater than 10. When it is greater than 10, how the function is defined? 21, and replace f of x by 21. That is limit extending to 10 plus 21, and limit extending to 10 minus f of x, that means slightly less than 10. When it is less than 10, the function is defined as ax plus b, replaces by ax plus b. And what is f of 10? When x equal to 10, it is 21, and f of 10 is equal to 21. And limit extending to 10 plus is 21 is equal to 21. and limit extending to 10 minus ax plus b is equal to a into 10 plus b is equal to 21, and that is 10a plus b is equal to 21, and call this equation as equation 1. Similarly, let us use this result, that is limit extending to 2 minus f of x is equal to limit extending to 2 plus f of x equal to f of 2. We will have this result. And when it is 2 minus, when it is less than 2, how the function is defined? 5. Replace f of x by 5 here, and we will have limit extending to 2 minus 5. Limit extending to 2 plus f of x slightly greater than 2. When it is 2 to 10, function is defined as ax plus b, that's equal to limit extending to 2 plus ax plus b, and which is equal to 5, because what is f of 2? When it is 2, function is defined as 5, see here, and it's equal to 5. And limit extending to 2 minus 5 is equal to 5, and this is a into 2 plus b. Just put x equal to 2 here, and put x equal to 2 here. A into 2 plus b is equal to 5, that is 2a plus b is equal to 5, and call this equation as 2. Now you have to solve these two equations to find the values of a and b. And solving equation 1 and 2, what is 1? 10a plus b is equal to 21, and what is 2? 2a plus b is equal to 5, and just equation 1 minus equation 2, you will get bb gets cancelled. 10a minus 2a is 8a, 21 minus 5 is equal to 16, and a is equal to 16 by 8, and that's equal to 2. You got the value of a, and substitute in any one of the equation. I'll substitute in the equation 2. You'll have 2a plus b is equal to 5. What is a here? 2. 2 into 2 plus b is equal to 5, and b is equal to 5 minus 4, and b is equal to 1, and thus you will get the values of a and b. And I'll consider one more question. For what values of lambda is the function defined by f of x equal to lambda into x square minus 2x if x less than or equal to 0, 4x plus 1 if x greater than 0, continuous at x equal to 0, and what about continuity at x equal to 1? You have to check the continuity at x equal to 1, and you have to find the value of lambda at x equal to 0. Now, given function is f of x is equal to lambda into x square minus 1 if x less than or equal to 0, 4x plus 1 if x greater than 0. Now, let us find the value of lambda if the function is continuous at x equal to 0. And at x equal to 0, what is f of 0? Lambda into 0 minus 0, and that's equal to 0. And limit extending to 0 minus f of x. Here 0 minus means less than 0. When it is less than 0, function is defined lambda into x square minus 2x, and that's equal to lambda into 0 minus 0. Put x equal to 0 here, and 0 minus 0 is equal to 0. Lambda into 0 is equal to 0. Here the left hand limit is 0. And limit extending to 0 plus f of x is equal to limit extending to 0 plus greater than 0, function is defined as 4x plus 1. Limit extending to 0 plus 4x plus 1, that's equal to 4 into 0 plus 1, and that's equal to 1. Here the left hand limit is 0 and right hand limit is 1. They cannot be equal for any value of lambda, and you can conclude like this: limit extending to 0 plus f of x is not equal to limit extending to 0 minus f of x. Therefore, f of x is not continuous at x equal to 0 for any value of lambda. Now let us check the continuity of the function at x equal to 1. And f of 1 is equal to, see here 1 is greater than 0. When x is greater than 0, function is defined as 4x plus 1. Therefore, f of 1 is equal to 4 into 1 plus 1, and that's equal to 5. And find the limit extending to 1 minus f of x. And here 1 minus means slightly less than 1, and that is maybe 0 0.999 or 0 0.9, 0 0.9999 like that. And when it is slightly less than 1, then x is greater than 0, and function is defined like this only, that is 4x plus 1 only, because nearer to 1 function is defined 4x plus 1 only, and that's equal to limit extending to 1 minus 4x plus 1, and that's equal to 4 plus 1 is equal to 5, and limit extending to 1 plus f of x. 1 plus is also greater than 0, and 1 plus f of x equal to limit extending to 1 plus 4x plus 1, and that's equal to 4 plus 1, and which is also equal to 5. And here left hand limit, right hand limit, and the value of the function are equal. Limit extending to 1 plus f of x is equal to limit extending to 1 minus f of x equal to f of 1. Hence f of x is continuous at x equal to 1 for all lambda, where lambda is any real number. Function is a continuous function. And with this much, I'll conclude this video, and I'll continue with some other problems in the next video. Thank you.